Okay, let's look at the question together. Pearson and Lee obtained the following results in a study of about 1,000 families. Average height of husband, 68 inches. Standard deviation, 2.7 inches. Average height of wives, 63 inches. Standard deviation 2.5 inches, okay? And the correlation coefficient is 0.25 inches. When I stop here, can anybody point out there's a mistake? Where's the mistake here? Anyone?
I guess we do.
Where is the mistake? Come on, you are not going to lose anything, right? Where is the mistake? Anybody want to try? R is just a number. R has no unit, okay? R is just a number. That means it carries what? No units. For this, you can look at my YouTube video on correlation, okay? It's very important you read it, okay? It's very important you read it. We want to predict the height of a wife when the height of her husband is 72 inches tall, 64 inches tall, 68 inches tall, or we don't know. When husband's height is what? Unknown. How can we predict what? The wife's height. Let's begin with what? 72 inches tall, okay? And from the regression what? Video, okay? Follow the least square criterion, the best prediction line. Is what? Regression line. If we follow the least square criterion, okay, and follow the least criterion, how can we find the best prediction line, the regression line? Well, say this is our regression line. Y hat equal to what? A plus bx. B is regression slope, and A is what? Y-intercept. Okay? So how we find B and how we find A? Well, B is equal to R. This is regression slope. B is equal to the correlation coefficient times what? Standard deviation Y over standard deviation X. Okay? And R is given. This is wrong, okay? No units. R is what? 0.25 times standard deviation Y. Okay, standard deviation Y is what? Actually, this is about 2.5 inches. Okay, 2.5 inches. And standard deviation X is what? 2.7 inches. Okay, so how you find the number? Let's see. So follow the formula. Slope is what? Roughly equal to 0.231. And how about y-intercept? Y-intercept is what? A. Okay, and A is what? Average Y minus B times what? Average X. Okay? So let's plug in the numbers to see what we get. Okay, so look at the formula. We use slope formula. B is equal to correlation times standard deviation y over standard deviation x. And that number is 0.231. And y-intercept A is equal to average y minus B times what? Average x. As you can see from the formula. To find the best prediction line, the regression line, slope and intercept, y-intercept, which one you should find first? Huh? You should find what? B first. Because in finding y-intercept A, you need to know what B is. So always find slope first, okay? You plug it in, you get the y-intercept is what? 47.26, okay? The unit, of course, is what? Inches, okay? So in this case, the best prediction line, the regression line. From here, you know, is y hat equal to A plus bx. And that is equal to A is what? 47.26 plus B is 0.231 times what? Times x, okay? The regression line is y hat equal to A plus bx equal to 47.26 plus 0.231 times x, okay? Now, we're going to do this one by one. First one, when husband's height is 72 inches tall, okay? So, A, y hat, you evaluate in when what? Y hat, you want to predict wife's height. When husband's height is what? 72 inches tall, okay? So all you need to do is plug in the numbers. This is 47.26 plus 0.231 times 72, okay? Okay, let's see. For what? Husband height is what? 72 inch. The wife you're going to predict is what? You plug in the formula, right? You get 63.892, okay? Now look at part B. If husband is what? Shorter, only 64 inches tall. How about the wife's? Okay, so you plug it, you just, this number replaced by 64. Let's see, what do we get? So after we obtain what? The best prediction line, the regression line, okay? Follow what is best. Follow the least square criterion, okay? For A, for those wives who have what? 72 inches tall husband, you're going to predict 63.892 inches. You just plug in the number into what? Into the regression line, okay? And then x equal to 64, this is replaced by 64. This is what you get. And when x is 68, you plug in here, you get 62.97, okay? And which is very close to what? 63, okay? Now look at here. X equal to 68. What's 68? 68 is what? Is average of x, okay? When the husband is average, the wife is also average. Can you see that? Okay. Now, the last one. If we don't know the husband's height and we want to predict the wife's height, how can we do that? Huh? Before, if you tell me x, I can just plug in x here and use what? The least square regression line to find what? The corresponding wife's height. But if I don't know the husband's height, how can I predict what? Huh? Or selected what? Wife's height. How can I do that? Well, the idea is very simple. If you don't know, you just estimate by what? By average y. If you don't know husband's height, and you want to predict a selected what? Wife's height. If you don't know the husband's height, you just use what? Average wife's height to make the prediction. And what's average y? average of the Y's in the given data set is what? 63. So just use 63 to predict what? A selected Y type, okay? This question is important in its concept, okay?